any time of the day and charges consumers accordingly. This information is also shared with the consumer both locally and remotely, allowing them to better schedule their energy usage if necessary. Smart grid utilizes high-speed sensors called phasor measurement units to monitor power quality. Ideally, the waveforms of alternating current should be identical throughout the entire grid. Phasor measurement units are integrated all through the system, allowing data to be extracted regarding a particular position's waveform dimensions along the grid. Networks with this level of unit installation make up a wide area measurement system and can provide real-time data. Along with phasor measurement units, wide area measurement systems include phasor data concentrators to gather sample data and route it to a supervisory control and data acquisition system at a control station. Data concentrators are linked to the units through existing phone lines and manage a range of between 12 to 60 units and relays the collected information to a central facility. An entire network worth of information in relation to these waveform patterns will allow for automated systems to better manage power system distribution in real time as inefficiencies occur. Information transfer technologies is needed to extend the two-way communication feature into home applications. Protocols such as Zigbee, Insteon, Z-Wave, and Wi-Fi are most popular. In a smart grid application, it is encouraged for all these technologies to be compatible with one another. Zigbee uses the IEEE 802.15.4 standard for wireless personal area network. The combination of low energy and fast startup time allows it to go into sleep mode often, while not in use, and start when required. Zigbee connections are arranged in a mesh-type topology, meaning it allows information to be passed through other Zigbee devices to travel a longer overall distance. This makes it a better choice when compared to other alternatives such as Bluetooth. Distributed generation will allow the connection of small-scale renewable generations such as solar, wind, fuel cells, and microturbines. Generation will be close to the load, which reduces transmission line construction costs and transmission power losses. Heat that is generated from the microturbines can also be captured to be used for heating purposes. There will also be an increased customer interaction as they can sell unused power back to the electric utility. Reliability will also be improved as there is a wide variety of different generation sources connected to the grid.
There are many benefits to a smart grid. Efficiency will be increased with distributed generation, smart metering, and energy management systems. Distributed generation will reduce the transmission line losses and enable heat to be captured to be utilized for heating purposes. Smart metering will enable energy management systems to control load to be running during off-peak periods. Reliability will be improved as well with wide area monitoring and protection systems. It will provide constant detection of disturbances at any portion of the grid. It will include capabilities to both localize and evaluate the disorder that occurred and react in real time to diminish or neutralize the problem. The environment is also a benefactor as renewable and environmentally friendly generation such as solar and wind sources can be utilized in residential applications. Smart grid will help countries meet their Kyoto protocols. Reducing demand on centralized generation facilities will also reduce the amount of emissions that will be produced. Regulations of the power system must be changed to give incentives for utilities that are willing to produce renewable and efficient energy. As utilities' revenue is proportional to the amount of power it produces, they are reluctant to take the necessary risks to address the demand and environmental problems that we face today. Smart grid components such as time-of-day pricing to reduce consumption during peak load periods will require a large investment with an uncertain rate of return, posing as an unnecessary risk for the utility. Power flows of the new power system will have to be recalculated as new distributed generators are connected to the grid to ensure that lines are within voltage stability and thermal limits. The voltage generated must also be regulated to the line's rated voltages. System fault levels will have to be reevaluated as well for protection and control purposes. Implementing a smart grid will require a large amount of economical investment. China is investing 7.32 billion, while the United States is investing 7.09 billion into smart grids in 2010.
A $65 million test project involving 6,000 households on Jeju Island was launched on June of 2009 by various Korean electric power companies to set up a fully functioning smart grid system by 2011. The project will utilize two 10-megawatt substation transformers, four distribution lines, and green energy facilities including a wind farm. Some organizations involved are Korea Smart Grid Institution, Korea Electric Power Corp, Korea Smart Grid Association, Jeju Special Autonomous Province, and the Korean government. The objective of this is to demonstrate the concept for a smart grid community with a low carbon and green growth strategy. Malta has contracted IBM 70 million euros to become the first smart grid country by installing 250,000 electric and water smart meters. Work is expected to be completed in 2012.
Smart grid is an opportunity to improve and upgrade existing distribution systems with modern technology. It will improve the reliability, efficiency, and economy of the power system, as well as address the environmental issues that we face today. Distributed generation will allow the use of alternative generation such as solar and wind to be utilized in residential and industrial applications. With the implementation of smart metering, time of use pricing will also help reduce peak demand. Investment into smart grid will also develop new technologies and markets in the near future.
Thank you for watching our presentation on smart grids.